Go. Okay, so today it is Monday, November 29th. And our objective today is really to, we want to be able to convert angles from radians to degrees and degrees to radians, okay? I'll let you write that down. So I drew a picture. So 1 radian, which is an angle, 1 radian. So a radian is an angle that equals the length of its arc. The length of its arc. It's suspended arc, but it doesn't matter. So in this case, theta would be 1 radian, okay? It is about 57 degrees because it's 180 divided by pi. That is 1 radian. 180 divided by pi, because that's your equivalent, okay? So if 180 equals pi radians, then we've already done example 1. Complete the unit circle for all significant angles. We've done that. So we've got all of our degrees, right? And we all have all of our radian angles that go along with it. So we know that a 5 pi 6 radians is also 150 degrees. One's in degrees, one's in radians. We know that a 4 pi thirds radians is also a 240 degree angle. We can rotate backwards and we can say negative 45 degrees is also a negative pi force radians. The thing I like is that if the radius is 1, then this arc length right here is actually whatever pi 6 is. Okay, I'll say that again. If we are indeed talking about radians, then this angle here, which would be pi 6, is also the length of this arc. So the length of this arc here is about 0.52. That's the length of it. If I were to measure it, strap a string to it, take it out, and then measure it, it'd be 0.52. That's the length of that arc. So the arc length and the angle are the same, okay? So 120 degrees. Okay, let's do this. 120 degrees. You guys look. 120 degrees. What's my radian measure? 120. What is it? 2 pi thirds. It's that easy. 2 pi thirds radians and 120 degrees are the same. Okay, good. Negative 30. We didn't put that on our circle. What do you think negative 30 would be? Well, yes. It's going to be a negative pi 6. Yes. Okay, negative pi 6. The rotation up to 30 is pi 6, so going backwards would be a negative pi 6. Thumbs up on that one? You can put them in if you want to. You can put your negative 30 degrees. You can put your negative pi 6 if you want to on your circle, okay? 420. 420 is going all the way around and then some, right? And then some. So we know that 420 is, let's see, it's 360 plus another 60, right? Which would be 2 pi plus, what? 2 pi, right? 2 pi, right? Where did I come up with 2 pi? All the way around. And then plus my pi thirds, right? So we could say it's 2 and 1/3 pi, or we'd probably call it 7/3 pi. Okay? 2 plus 1/3, 2 1/3, or 7 pi thirds, right? Now, example 3. 3 pi fourths is a radian. Let's change that to degrees. So I'll look at my circle. I'm looking for 3 pi fourths. Did you find it? So it's going to be a 135 degree angle. Okay, show me thumbs up. I really want to make sure. For check. Check, everybody good? Everybody checking? Okay. Negative pi halves. Well, what do you think negative pi halves would be? Negative 90, because pi halves is here at 90. Negative pi halves is, Well, we got to be careful. Great question. I'm negative.
Or would it be negative 90?
It's got to be negative 90 because we only rotated this much. We didn't rotate all the way around. I'll show you again. It's like, Kai, you're a sprinter. And if you and I are here, and it's okay, Kai, I want you to go over to the high jump pits, you would not do this. Wolfman would make all the distance runners do this. My sprinters would just jog there, right? Yeah, pretty much. Okay, now, 7 pi thirds, we just did it. 7 pi thirds, we know, is the same thing as 2 1/3 pi, right? That's the same thing as a 2 pi plus a 1/3 pi, right? I mean, we did it, but now we're going to work it backwards, which is 360 degrees plus my 60 degrees, which makes my 420 degrees. How am I doing, okay? Now, example 4. Well, I'm recording, let's make it quick. What is it? Well, it hung up good. So, first of all, 130 degree angle. Let's take a look at this. This one's easy. I know 130 degrees. Oh, I don't need a protractor. I don't have to do it perfectly, but I know 130 degrees is just about right there as far as rotation. You guys okay with that? It's not perfect, but close enough, okay? Now, when they want two angles that are in the same spot, we're going to...
This way and this way.
Exactly. So, you find a nail on your car tire, you're bummed, you could spin it all the way back around. So one coturn will be 130 plus 360. It'll put you in the same spot, wouldn't it? So I would have, what's that, a 490 degrees? So 490 degrees and 130 would be in the same position, right? And then the negative, I would take my 130 and spin it backwards, right? Spin it backwards. And what's that, negative 230? So all three of these put that darn nail in my tire directly in front of me, correct? Does that make sense? Same spot, just a different way to get there, okay? So in radians, we're going to have to spin it around, but we're going to add 2 pi to it, because I would spin it all the way around. So if I were to draw first 5 pi 6, we did that a little bit on our circle. 5 pi 6 is about there. That's my 5 pi 6. It's about 150 degrees. So if I rotate it all the way around, I've got to add 2 pi to it, so that's going to be the same as 2 5 6 pi, okay? Or 17 or 17.6. Same answer. Or I could take my 5 pi 6 and I spin it backwards, right? Just spin it backwards, which means I have to subtract 2 pi. Okay, now let's see if we can do this, okay? Let me help you out with this. If you can't do fractions, you'll see it in a second. Okay, I just changed the number 2 into 12.6. You okay with that? The number 2 I changed into 12.6, so I'd have a common denominator. And if I subtract, I get negative 7 pi 6. Oh, negative 7 pi 6. So all three of these angles are in the same position. It's just a matter of rotation, okay? Okay, return the page. Now, here's our problem. We cannot put every single angle on our unit circle, correct? That'd be dumb. So we have to have a conversion. So we're going to go degrees to radians. So write this down. If you have degrees to radians, then your radians is going to equal, okay? It's going to be your angle over 180 times pi. Okay, write that down, okay? So let's do example 5a. Well, I know 100 degrees is about here somewhere, right? And it should have some radian, right? We should be able to figure that out. So 100 goes in for theta. It's this easy. Your radian is equal to 100 over 180 pi, all right? Now, if I can reduce that, I will. I'm going to reduce to 5/9. You okay with that? I'm going to reduce it. I'm going to reduce that fraction. Keep it in terms of pi if I can. 5/9 pi, okay? Sometimes you can't really make it into a reduced fraction with pi. So sometimes we're going to have to use our formula and have a decimal. Okay, so I'm going to use my formula. I'm going to say the radian is equal to my 112.26 over 180 times pi. And this time we're going to have a decimal answer. Okay, so I'm going to take my calculator and I'm just going to go, okay, what is 112.26 times pi divided by 180, and I get this answer of a 1.96 radians. Okay, now this is a teaching moment for me. That is an angle. It doesn't look like an angle. That is an angle. You know what? That is 3.14, isn't it? We call it pi radians, but that's really 3.14. That is an angle, 3.14. This is an angle. It doesn't look like an angle, does it? 1.96, well, we know it's about 112 degrees, right? It's an angle. Okay, now, our other way to convert is to take, we're going to have a second formula. Our second formula is going to go degrees to radians. So our degree is going to be our 180 over pi times our radian, okay? Same formula, but it's just the reciprocal, right? So if I take my 7 pi 12ths and plug it in right there, okay? So I'm going to go...
Please excuse this interruption. All winter sport athletes, if you have not gone to the testing area, please do so. All winter sports athletes to the testing area.
Okay. Okay, you see what I did? Kai, I think you're fine. Yeah, I'll finish it up. Okay, so I just put this angle right in there. I put it right there. See, I did that? And now what's the first thing you notice? Tell me the easy stuff. What's the easy stuff? Yeah, cancel the pi's. I'm just going to use my calculator. Then cancel the pi's. What is? Well, it's going to be 180 times 7 divided by 12. It's about a 105 degree angle. So in terms of degrees, this one would be about 105 degrees. How am I doing? Now, 2.7, that's an angle. 2.7 is somewhere in here. It's got to be. If that's 3.14, you with me? 2.7's got to be in here somewhere, right? I don't know what it is. I don't know what the angle is, but let's find out. So I'm going to take my 2.7. I'm going to go, my degree is going to be 180 divided by pi times 2.7. Now, pi's won't cancel. I'm just going to use my calculator. I'm going to get a decimal answer. I'm going to go 180 times my 2.7, divide that by pi, and I get this answer. I get 154 degrees, and now I want minutes. I want minutes. I want minutes. So I'm going to take the decimal part of this. So take your decimal. For us, our decimal was our 0.698, blah, blah, blah. And if I multiply this by 60 minutes, right, times 60, I'll get minutes, because minutes pop up in navigation. So minus 154. I just took out the 154. So I'm going to multiply my decimal times 60, and I get about 42 minutes. So my angle is going to be 154 degrees and about 41. See the little hash? That means minutes, okay? And you'll see minutes in navigation. Okay, how did I do? Thumbs up?
So you just took the end of the decimal on
Yep.
154
Yep.
and then times it by 60?
Yes, so I'll do it again. So I had the 180 times 2.7 divided by pi, okay? So let's look at this number, okay? So I know the answer's got to be 154 something, 154, right? So for me, because I want to find an easier way to